Hey everybody, Mr. Piercy here, and what we're going to be looking at today is not how to necessarily prove triangles are congruent, but to take the congruent shortcuts that we've seen, side, 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 angle, angle, side, maybe, hypotenuse, leg. We're going to take those shortcuts and we're going to be using them to prove triangles are congruent, and then we're going to extend it one step further to show that a different part of those triangles have to be congruent also. So what we have in this example here, it says explain how you can use given information to prove that segment DC and segment AC are the same. Now what it does say, again, just for the time being, try not to pay attention to the solution where it's giving you the paragraph proof. Let's just look at the figure itself. Now it does say, at some point it's going to say, well, copy the diagram down, which doesn't make any sense. Just use the diagram that's there. So what we know is that angle 1 and angle 2 are the same. So I'm going to mark them on the diagram to show that they're the same, because I like to have a visual reference. Sometimes they mark them for you to show you where it's given. Sometimes they just give you the information as a statement and it's up to you to mark them. Sometimes they give you both. It just kind of depends on the problem. So we know that those have to be the same, and AB and DE have to be the same. So AB and DE, so I'm going to mark those. Now, that's all the information that it gives us. Now with that side and the angle, the exterior angle of a triangle, right now that's not enough information. But knowing what we know about other topics from geometry, we can make a couple conclusions based on what we see. Well, angle 1 and angle ABC, those are supplementary angles because they form a linear pair. Same thing with angle 2 and angle DEC. Because those angles are supplements to the same value, whatever 1 and 2 are, then those angles must be congruent to each other also. That's actually known as the congruent supplements theory. I also can recognize at vertex C, I have angle ACB congruent to angle DCE because they're vertical angles. So now I have a couple of angles inside of a triangle and I have a side of the triangle. So I can actually show that the triangles are going to be congruent to each other by angle, angle, side. And if the triangles are congruent to each other by angle, angle, side, I can absolutely show that this statement must be true. Now let me explain what we're looking at here. We want to say, what is the reason why we would say that? So here is the reason, and it's a bit of a long one. Corresponding parts of congruent triangles are congruent. So that is actually a relatively long reason if you were trying to write it out as a paragraph proof or as a two-column proof. So what we do to, because we get lazy, is we are going to just make an acronym. We're going to just take the first letter of each word there, and we would refer to that as CPCTC. And you could just write that down as your final reason. So here, again, they're kind of giving it to us as a paragraph proof. So the thinking here is that if I can show these triangles are congruent, then I can show that their parts are the same. So first thing I'm going to recognize again is that I have a pair of supplementary angles and that these angles are also the same. So if we can show that the non-included side of the triangle is congruent, then I can show that the triangles are congruent by angle, angle, side. And then finally I can say, because corresponding parts of congruent triangles are congruent, CPCTC, that DC and AC have to be congruent to each other. So all we're doing now is we're going to be taking triangles and we're going to try and show that they're congruent to each other. Now the added challenge to this part is that now you have multiple ways of proving triangles are congruent to each other. There's not a specific one that you're going to be looking at because, well, you're working on that assignment. So you have to be able to recognize what congruence postulate would I want to use to show triangles are congruent, and then we'll probably need to take one extra step by then saying once the triangles are congruent, then we can say the corresponding parts have to be the same also. So here's an example where they're trying to show you how it can be applied outside of just a classroom. So we have these docks A and B, and the boats are tied up at them, and maybe we want to know how long of a rope we need to have to tie those things together, or we're going to build a connector between them. I don't know. So what they're doing is, well, we can't measure the distance between A and B directly because it's over the water. But if we create a set of congruent triangles, then we can measure its length indirectly. So they're giving us a kind of a diagram here. They're saying we're going to place a marker at D so that way they're perpendicular to each other. And then we're going to say, well, let's make this point here, let's make it a midpoint. So in the diagram here, that's why we're able to say that CD and BC, or CD and CB are the same. And if DE is perpendicular to BD, then AB will be perpendicular to BD also. So here, these angles at the vertical angle point where point C is, those angles also have to be congruent to each other because they're vertical angles. So what I'm looking at in this diagram is I'm really looking and saying, well, we have two angles and a side included in between them. So that's the angle side angle congruence theorem. So if I know that those triangles are the same, then I could easily, because it's on land, measure the distance between DE and between points D and E, and therefore I will know the distance between A and B. So that's kind of what we're looking at here when we're trying to plan out our proof, saying how we're going to show the triangles are congruent, and then therefore the corresponding parts of the triangles are congruent. And here it is, kind of written out for you in a long corresponding parts of congruent triangles are congruent. You can see why we would abbreviate it CPCTC, because it's a lengthy thing to say for such a simple statement. So here we have a couple of problems. You guys, at this point, I want you to go ahead and pause the video and try and answer these questions yourselves. Now, this is problem number one especially is very similar to several kinds of problems that you'll be expected to be able to answer. How you answer them is your choice. You have to be able to justify it in some way. Personally, I'm going to go with two-column proof when I answer this one, but that doesn't mean that you have to try it that way. I know that on your assignments, on your assessments, there are going to be two-column proofs, so that's why I wanted to use that example particularly. But go ahead and try answering these questions yourselves, and when you're finished, come back and compare your answers against mine. All right, guys, let's see how you did. So in problem number one, what I'm looking at is I'm going to say, well, what do I know about it? I want to show that PR and QS are the same. Well, PR and QS are kind of like the diagonals of what looks like it might be a trapezoid. So based on what we know that TS and TR are the same. That was given to me. And angle SPR and angle RQS, that was also given to me. But I also know that here at point T, those vertical angles, PTS and QTR, that those angles are the same. So here, let me try and highlight what I'm looking at without corrupting the image too much. I'm looking at kind of this triangle right here, and I'm kind of looking at, let's try yellow. Looking at this figure right there. We're looking at those two triangles. Based on what I'm seeing there, I can I can claim that those triangles are congruent by angle side, because I have two angles and a non-included side inside of both triangles that correspond and are congruent to each other. So if those are the same, then we can have something to work on. Well, but what we're looking for is from Q to S and from P to R. So there's a little bit more thinking that we have to do here. Well, I know that if the triangles are the same, then this part here and this part here have to be the same because corresponding parts of triangles are the same. And so if I add those two smaller segments together, then the whole segment that I'm looking for, PR and QS, have to be the same. So let me go ahead and show you how I put it out as a two-column proof. I tried explaining it because that's what I do. I try and think my way through the problem before I really try writing the proof. So I'm going to take the given angles that were given to me. I'm going to take the vertical angles that we could see, and then I'm going to take the side that was given to me, and then I can say that the triangles are congruent by angle, angle, side. So that means that PT and QT have to be the same because corresponding parts of congruent triangles are congruent. So now I'm going to add the segments together using segment addition, and then I can say PR and QS have to be congruent to each other because, well, that's what the definition of congruent figures are. They're the same size and same shape. So now here in example 2, where am I going to place the marker? At point D, you should basically just place it far enough so that way it's on land. That way it allows segment DE to be easily measured. Alright, so let's see how we are looking at this example on 3. Use the given information to write a plan for a proof. Now again, I'm not a big fan of them saying a plan for a proof. If you're going to write a plan for a proof, just write the proof because essentially they're the same thing. So write the proof. Well, I guess I probably shouldn't have. There you go. Write a proof. That's really what we're going to be looking at. And all what we see here, this is the proof. It's a paragraph proof. So again, I'm not going to look at any of the given information. Let's just look at the diagram. I'm sorry, I'm not going to look at the solution here. Just pretend that it's not there for the time being. Because if you can think your way through the problem first, then you can write out all of the statements that you need for your reasoning relatively easily, whether you use it as a paragraph proof or as a two-column proof. So look at the figure first. We want to show that triangle ABD and triangle ACD are the same. So angle 1 and angle 2 are the same, so that's given to us. And angle 3 and angle 4 are the same, that's also given to us. So what we're looking for is we want to prove ABD. We want to show that this triangle here, and let me pick a different color here, triangle ACD, this triangle, we want to show that those two triangles are congruent to each other. Well, what am I going to look at? How am I going to show that those triangles are congruent to each other? Well, looking at the diagram, we have angles here. Let me pick another color. Let's go green. This angle here and this angle here at vertex D, those angles have to be the same for similar to what we saw in example 1. They're supplements to the same angle. So according to the congruent supplements theorem, those angles have to be the same as well. Segment DE in both figures has to be the same. So we can start by trying to say that we have a couple of smaller triangles. We have triangle BED and we have triangle CED that we could show are congruent by the angle side theorem. Okay, well, how does that help me show that the red and the blue triangle are the same? Well, once I know that certain triangles are the same, then I can start saying, well, other parts of those triangles are going to be the same also. So we definitely would be able to claim that BD and CD would be the same according to let's go ahead and mark those. CPCTC, oops, that's one too many. According to CPCTC, and this side right here, AD, is shared between the red and blue triangle. So looking at that information, I can see, well, it looks like I would be able to prove the red and blue triangles congruent by side angle side because I have an angle included in between the two sides that we have. So I think that's what we're going to go with. And if we had to write that out as a two-column proof, that's the thought process that I'm going to go through to see, well, how can I show that the triangles are the same? Well, here they're giving us a convenient paragraph proof where all we have to kind of fill in is the blanks. So again, we know angle 1 and angle 2 are the same, and if we can show the triangles are congruent by side angle side, or we can use side angle side to show that BD and CD are going to be the same. Wait, if you can show that BD and CD are the same, then the side angle side postulate uh, will help us to figure these. And that's what I said at the end. That's side angle side. So to prove, going through it here, we're going to prove triangle BED and CED are the same, and that's exactly what I did first. And the reason why we're going to do that is really going to be by angle side. And so if those triangles are congruent, then we can use parts of the triangles to be congruent to show the triangles that we're looking for have to be the same according to the side angle side postulate. So here it's given that the figure is particularly a little confusing, and it's meant to look that way. It's meant to be a bit of a challenge. So given what you have here, and again, I'm going to be upfront and say before you try working out your answer, when I do it, the answer that I give is a 2-column proof. So if you whether write it as a paragraph proof or as a 2-column proof, either way, go ahead and attempt answering the question, show triangle FJK and LHJ are the same, and then come back and compare your answer against mine. Okay, so let me just go ahead and pop my proof up here on the board because it is a little bit long. Given the sides and the angles, or taking the given information for the sides and the angles, I'm going to just start with those. Then I'm going to be able to say that triangle FJK and LHK are right triangles because, well, if a triangle has a right angle, that's the definition of a right triangle. Then I can say HJ and JH are the same because of the reflexive property. And then I'm going to add those segments together to, again, show that GJ and KH are the same according to segment addition. So moving on, I can say GJ and KH and FG and LK are the same because, well, that's the definition of, I'm sorry, GJ and KH are congruent to each other because, well, that's what congruent segments do. And so the triangles have to be the same according to hypotenuse leg. So if the triangles are congruent to each other, then segments FJ and LH are congruent to each other. Then I can say the angles FJK and LHG are the same because of the congruent supplements theorem. And then finally, I can show that triangle FJK and LHG are congruent according to side angle side. So you can definitely see that the proofs that we're looking at are going into a little bit more detail as far as how we're trying to prove certain things are the same. And we're not just trying to prove triangles are the same, but we're trying to show, particularly at a point like this, the corresponding parts of triangles are the same. So let's move on here and see how we can look at a proof like this. So write a proof to verify the construction of an obtuse angle is valid. Okay, so we have these two angles, CAB and FDE, and what we want to know is, well, why are they going to be the same? So it's telling you to add segment BC. I don't think I put those in there as a, yeah, let's just go ahead and draw them in there. So add BC and add FE. And so what we're looking at here really is going to be an isosceles triangle. Okay. So if we're adding an isosceles, what we're doing is essentially making an isosceles triangle, then we're able to try and show that the triangles that we'll see here must be congruent by side, side, side. So let's just go ahead and start with the given information. We're given that AB and DE are the same because the way that we constructed them with a compass, essentially DE and DF, AB, and AC, there's simply a radius of the same circle. So what we want to show is that these angles here, angle D and angle A, that they have to be the same. That's ultimately what we're trying to show. So I'm going to write a proof that shows that these two triangles are the same, so that way I can conclude that those corresponding angles are the same. So I'm going to take the stuff that was given to me, the three sides, and then I can say that the triangles are congruent by side, side, side. So if the triangles are congruent, then these angles D and A also have to be congruent. Now, I really do like this problem, even though it's, talking about doing it as a construction as opposed to just something that was given to you, because this was a nice, simple proof, nice rule, a good example of a two-column proof that you could be expected to know how to do. Okay, now here it is saying write a paragraph proof to see if the construction here is valid. Okay, and I want you to go ahead and pause the video and try and reason your way through answering this question. And when you're done, when you're ready, hit play, come back and compare your answer with mine. All right, so what we're doing is we're bisecting a right angle. So if I bisected a right angle, what I'm doing, see this mark here, it's a little it's like a little bit of a curve. So what I'm doing is I'm showing that this segment and this segment are going to be the same because essentially they're the angle of a or basically it's just a radius of a circle. Okay, so if those sides are the same and these sides, because again we're doing it with a compass, so this side here and this side here are going to be the same. Well, this side here is obviously shared between them, so I will be able to show that the triangles themselves have to be so the triangle ACD and ABD, that they're going to be congruent to each other according to side, side, side. And if the triangles are congruent, then angle CAD and BAD have to be the same because corresponding parts of congruent triangles are congruent. That's going to kind of wrap it up for this lesson, guys. What we're looking at, again, we're utilizing all of the potential proofs, or not proofs, but triangle shortcuts that we have for proving triangles are congruent now. And we're going to take an additional step, at the very least, to not just prove triangles are congruent, but to show that their corresponding parts are congruent also. So as you watch over the video, again, make a note of any questions that you may have and send them to me. Otherwise, guys, thanks for watching. Take care, and we'll see you soon.